Okay, so this lesson is involving solving inequalities with one variable. Sometimes the variable can be on both sides of the inequality. So we're going to do a couple of examples here to demonstrate what this looks like. So I'm going to take example B right here. I'm going to write it over here to the side. 2 times the quantity minus 2x. There we go. Is greater than 1. So the main rule to remember with inequalities, everything with solving an inequality is just like an equation. The exception, if you multiply or divide by a negative number, you must flip the sign. That's the only rule. Otherwise, it's exactly like solving an equation. So we're going to work this one out. So we distribute. It's going to give us 8 minus 4x is greater than 1. Then subtract 8 from both sides. So I get negative 4x is greater than negative 7. Now I'm going to divide by negative 4. Since I'm dividing by a negative 4 here, then that means I've got to flip my inequality symbol. So these cancel. Got x. Now I flip my inequality symbol. And then I have negative 7 over negative 4, which would be 7/4. Now, when we're graphing the solution, that just means we're on a number line. If your variable is on the left-hand side, whichever direction your quote-unquote arrow points, that is the way you shade or graph. So 7/4 is actually 1 3/4. It's probably a good idea to change these to a decimal or fraction. So if I'm on a number line, say this is negative 2, negative 1, 0, 1, 2, 3. 1 3/4 would be approximately here. Now, what I'm going to do is I'm going to put an open circle. And the reason I put an open circle is because this is not equal to. It is just less than. My quote-unquote arrow points to the left, so then I shade to the left, and I put an arrow on the end. So what that means is x is any number less than 7/4 or 1 3/4. Which means any number less than that, if I were to plug it into this inequality statement, it would make it true. Okay, so let's look at another one. Let's take A here. So again, I'm going to do distributive. I'm going to try to save some time here. So I've got negative 8x plus 4 is less than negative 8x plus 4. Okay, so this looks kind of unique. It looks like an identity, okay, because they're the same. But if they're the same, that means they must be equal. Well, what that tells me is this can never be less than this, because they're equal. They can never be less than one another. So that, in math, again, is considered a false statement. Anytime we have a false statement, that means there's no solution. If there's no solution, that means graphically we can't do anything. Now, the second example, however, negative 6x minus 5 is less than, again, I'm going to do my distributive. If I do my distributive, I get negative 6x minus 3. They're different, so I'm going to add 6x to both sides. That's going to get that. Now I've got negative 5 is less than negative 3. Okay, is negative 5 less than negative 3? The answer is yes. When is it less? Always. It is always less. So this is a true statement in math. -5 is less than -3. So if it is always true, then that means my solution is all real numbers, or as we learned in one of the other lessons, infinitely many solutions. What that means graphically is if I have a number line, I'm going to shade the whole number line and put arrows on both sides of it, because that means it's going to be any number would make the statement true. So, in summary, when we're solving, okay, the main rule, as it states right here, when you are dividing by a negative or multiply by a negative, you must switch the inequality symbol. You must switch the inequality symbol.